Okay, so we're going to look at problem 1.59. And 1.59 relies on the definition that 1 mole is equal to 6.02 times 10 to the 23rd things. And in this case, the things we're counting are atoms. And so if you have a mole of atoms, it has the mass of the molecular weight. And that's where this number comes from. It's a way of counting things, and it comes from chemistry and atomic physics. But it is a quantity of things, which is one of our dimensions. And so they're saying if 3 moles of atoms were spread uniformly over the Earth's surface, how many atoms would there be per square meter? So we want atoms per square meter. So we start with 3 moles. We're going to multiply that by our conversion factor, 0.602 times 10 to the 23rd things, and in this case our things are atoms. You'll see when we do thermodynamics that you can have moles of other things than atoms per mole. And so that gets us the first part of this. This is going to give us atoms, but we're going to need atoms per meter squared. So that per is a big division. So I'm going to draw a secondary division bar here. Nice big division for that word per. And it's per meter squared. And we're spreading these atoms over the surface of the Earth. Earth can be modeled as a sphere. We're spreading over the surface of the Earth. We need meters squared. So we're looking at the surface area of a sphere. And so the surface area of a sphere is equal to 4 pi r squared. So that's going to go down below everything because of the per surface area. Per is a division. So 4 pi, I'll put some parentheses, and the surface of the Earth in kilometers is 6.38 times 10 to the 3rd kilometers for our radius here, squared. So I'm almost home free. They want this meters squared, so this kilometers here, I'm going to have to convert. Well, this division by 1 here is going to cancel the moles. So let's simplify what my equation looks like here. Not even an equation, it's really an expression right now. All right. 3 times 6.02 times 10 to the 23rd atoms over 4 pi times. Now, to fix this here, I'm going to use my definition of kilo. Instead of doing a conversion factor, I know that kilo is times 10 to the 3rd. Keep my meters squared. And so if I do my unit analysis, I know I'm going to get meters squared here, so I'm going to have atoms per meter squared. So I now have something I can put into my calculator. My rule of exponents says these are going to just become 10 to the 6th. So one more, I'll scroll this up and write it nice and neat in the format that'll go into my calculator. So that's 3.602 times 10 to the 23rd atoms, all over 4 pi times 6.38 times 10 to the 6th meters squared. And I plug away on my TI-89, and I get 3.5307. I only need 3 sig figs, 3.5, 3.53 times 10 to the 9th atoms per meter squared. And so there's about 3 billion atoms per meter squared if you were to spread a mole across the surface of the Earth. Um, that's a considerable amount of atoms in each meter. And so that 10 to the 23rd is a really big number. And you'll see as you do chemistry and we do some more molecular or atomic physics and thermodynamics, we have to deal with a large number of things. And a mole is a useful unit for dealing with that.